Hello students, now today we are going to start the next topic, that is refractive index. So what is refractive index? Refractive index is a property of any substance, any medium, which decides the speed of light through that medium. Generally the refractive index is represented by the small letter n. And we can define it, or we can give the definition like that it is the ratio of the speed of light in air. This is the speed of light in air or vacuum upon the speed of light in the medium. V is equals to speed of light in medium. So what is the refractive index? It is the ratio of speed of light in air or vacuum to the speed of light in any medium. This value of speed of light in air or vacuum, it is equals to C is equals to 3 into 10 to the power 8 meter per second. And students, you have to remember this value. Okay. So the ratio of speed of light in air to the speed of light in medium is called refractive index of that medium. This simple refractive index, it is also called as absolute refractive index. It is also called absolute refractive index. Means simply we can say it refractive index or absolute refractive index. Both are the same thing. So we can say that it is called the refractive index or absolute refractive index, no problem. Now students, for the relative refractive index, what happens? Now listen, you have to remember n is equals to refractive index, C is speed of light in air or vacuum, and V is speed of light in medium. Now students, what is the main thing? That suppose there are two medium, okay? And the refractive index of first medium is n1, the refractive index of second medium is n2. Suppose a light ray move from one medium to the next medium. Since here the light is having velocity v1, and whenever it enters to the next medium, let's consider its velocity become v2. So from this we can calculate for the first medium the value of refractive index will be n1 is equals to C upon v1, and for the second medium n2 is equals to C upon v2. These are the values of refractive index for their medium. Now if we relate both the refractive index, means compare both the refractive index, then we can divide both these equation like n1 upon n2, then it will be C upon v1 upon C upon v2, C and C will get cancelled, and we will get v2 upon v1. So in this way we will get a relation n1 upon n2 is equals to v2 upon v1. This n1 upon n2, we can write this value as n12. That means refractive index of medium 1 with respect to second medium, n1 upon n2, it will be equals to v2 upon v1. So whenever we compare the refractive index of first medium with the second medium, then it will be equal to velocity of light in second medium to the velocity of light in first medium. Similarly, if we are calculating the value that is n2 upon n1, then it will be equals to v1 upon v2, or we can say n21, that is refractive index of second medium with respect to the first medium, will be equals to velocity of light in medium first to the velocity of light in second medium. These are actual relation, and in this way the relations are given in our book. Okay, so this is the relative refractive index. These values, these are called as the relative refractive index. Okay, fine. Now students, the next thing is about, since I told you about the refractive index, the refractive index of air is minimum, that is equals to 1, and the refractive index of diamond is maximum, it is equals to 2.42. It is maximum. Diamond have the maximum refractive index, the refractive index of water is 1.33, refractive index of glass is 1.352, like this. Okay, now the next thing is, students, that the next topic is about the optical density. So what is optical density? Actually, every medium has the ability to refract the light ray, and that ability is called optical density. Okay, generally means we have seen that the every medium is having the ability to reflect the light. Generally, if the medium is denser, it will reflect, means it will have high refractive index, and the medium having low refractive index is optically rarer. I told you that the medium having value of refractive index lesser, it will be rarer medium, and the medium having more refractive index will be denser medium. So whenever a light ray move from rarer to denser medium, suppose this is rarer medium and this is the denser medium, then it will bend towards the normal. Why? Suppose its refractive index is n1 and its refractive index is n2. So when n2 is greater than n1, that is light ray move from rarer to denser medium. In that case, the light ray, refracted ray will bend towards the normal. And whenever, suppose this is a medium, okay, this is n1, that is denser medium, and this is n2, that is rarer medium. So whenever light ray move from a denser medium to the rarer medium, then the refracted ray will bend away from the normal. In this, you can see this is angle of incidence I and this is angle of refraction R. Here, when light ray move from rarer to denser medium, in that case the angle of incidence will be greater than angle of refraction. And here, when light ray move from denser to rarer medium, this is angle of incidence, this is angle of refraction. In this case, the angle of incidence will be lesser than the angle of refraction. So this is the optical density. So what is optical density? The ability of a medium to reflect the light, it is called optical density. So any medium have the ability to reflect light, and the maximum, the medium having high refractive index is optically denser, and the medium having lesser refractive index will be optically rarer medium. Okay.